Okay, factoring quadratics. We're going to call it a lot factoring trinomials. I think that's what delta math will call it mostly, but they are quadratics. Factor these completely. Pause it here real quick. This is what we did in the last lesson. Try it and see if you can remember how to do it. Okay, so the first one I'm going to have 4y in common. So I can factor out a 4y. I'm sorry, just 4y squared actually, right? 4 goes into both of them. I don't have an x in both of them. I do have 2 y's. So that 4y squared is going to go on the outside. And I'll have negative 11 x to the fourth y to the fourth plus 6. The y squareds become 1, z squared. Now, for the record, if you wanted to take out negative 4y squared, well then this would be negative out here, and a negative divided with negative would be a positive, and a positive divided by a negative would be a negative. This would also be an acceptable answer if you wanted to factor out the negative. So for example, let's go ahead and factor out, looks like 6 goes into both these. Let's do negative 6. Just how much it changes the signs and that kind of thing. And I've got no x's in common, but I've got y cubed in common and a z in common. So I'd get negative 6y cubed z, negative 30 divided by negative 6 is positive 5. Y to the fifth divided by y to the third is y squared. Z divided by z cancels out, becomes 1. This would be positive. Negative 48 divided by negative 6 would be positive. We're not dividing any x's. Y cubed and y cubed would become 1. Z cubed over z, z squared. If you had just factored out a positive 6, you'd have gotten that. Just change the signs. I forgot my 8. I'm sorry. But if you factored out a negative 6, changes the signs on the inside. This is going to come into play what we do here from now as well. Okay, quadratic expression, an algebraic expression of a single variable with the highest power being 2. X squared plus 2 is a quadratic. 3x squared minus 2x plus 1 is a quadratic. 7x squared, anything with the highest variable power of 2. So factoring quadratics, often take the form of ax squared plus bx plus c. When a equals 1, means the number right here in front of the exponent, number in front of x squared is 1. So this is now a equals 1, a equals 3, a equals 7. So here a equals 1. I may have done this before. You want to know what multiplies to c and adds to b. What multiplies to 12 and adds to 7. So we go through all things multiply to 12. 6 times 2 won't add to 7. 3 times 4, probably get that to work. 3 plus 4 is 7. So 3 and 4. And it's all pluses. We want them to multiply to positive 12 and add to positive 7. So it's 3 and 4, so that means it factors into x plus 3 times x plus 4. And if I FOIL this back together, x squared plus 4x plus 3x plus 12, which is x squared plus 7x plus 12, which is what I started with. That's the whole point. We're unfoiling essentially now. So you try this one. Figure out what multiplies to 12 and adds to 8. So 3 and 4 didn't work, but 6 and 2 do. So it's x plus 2 times x plus 6. Because 6 times 2 is 12. Positive 2 plus positive 6 is positive 8. Now try it with negative 12, x squared plus x minus 12. You want it to multiply to negative 12, but add the positive 1. So 6 and 2 won't work, because we can't get to that positive 1. But 3 and 4 again. I need one of them to be negative and one to be positive, so they multiply to a positive. But I want them to add to a positive. So that means I want the bigger one to be positive and the smaller one to be negative. Because negative 3 plus 4 is positive 1. So it's x minus 3 times x plus 4. Okay. Other ways to factor, just other ways to think about these things. If you like it like this, do it like this. If you want to think what multiplies to 20 and adds to 9, you can probably figure that out. But if that doesn't work for you, think about numbers that add to 9. And again, this is kind of a guess and check. Well, 9x is the same thing as x squared plus 4x plus 5x plus 20. This would just be 9. Now, we're going to do what's called factoring by grouping later, but might as well start it now. I'm going to take these two and these two and just factor them. Okay? So I can factor out an x. And divide this by x, divide this by x, and put the x on the outside. So I'd have x on the outside, and then x squared divided by x, 4x divided by x. Now over here, I'm going to do the same thing. I'm going to factor out a 5. And I'm going to get x plus 4. Now the idea here is I have x plus 4 in common. So essentially what I'm going to do is divide both of these by x plus 4. And now the x plus 4 is my common factor that I put on the outside. And now this cancels out with this, just leaving me x. And this cancels out with this, leaving me that. Just another way to look at it. Some people like that, some people don't. If you're good at, thinking about what multiplies to x or multiplies to c and adds to b, you can do that. Here's where it gets a little trickier, just something to think about. Okay. So what adds to 11 or negative 11? Negative 5 and negative 6. Okay, so here's the tricky part. I'm going to take out an x out of both of these because we're going to factor this one. And so put the x on the outside, x minus 5 on the inside. Well, now if I want to factor out the negative 6, I'm going to divide this by negative 6 and this by negative 6. So what I'll be left with is positive x, because the negative 6 is now on the outside, but that makes that negative positive. And 30 divided by negative 6 is negative 5. The idea is you want these to be the same anyway, but this changed because I factored out a negative 6. Okay? And now I can factor out the x minus 5 here and be left with x minus 5 times x minus 6. Which again, if you can figure out negative 5 times negative 6 is positive 30, negative 5 plus negative 6 is negative 11. Just another way to think about it. And it kind of gets us to where we're thinking about factoring by grouping, which we'll do later on down the line. Now, when a is not 1, a here equals 2, not 1. We can't just do what multiplies to negative 30 and adds to 7. So first, you multiply A and C. So we get 2 times negative 30 be negative 60. Then figure out what multiplies to that, what multiplies to A times C, and adds to B. And there'll be other numbers. It won't just be 2 and 30 in this case. So multiply A and C, we get negative 60. So this is where you have to start doing some guess and check. You want something, 2 numbers that multiply to negative 60, but add to 7. So one of them's got to be negative. So you're looking for 2 numbers that are 7 apart. Okay? So 10 and 6 won't work because they're only 4 apart. 2 and 30 aren't work because they're 28 apart. 3 and 20 won't work because they're 17 apart. So anything else that can go into 60, I can think of 5. We tried 10, so we try 5. 5 is 12 and 5. So 12 times 5 would be 30. And then you could do 12 minus 5 would be positive 7. So it's 12 and negative 5. But then we have to do the grouping like we just did. It doesn't really matter the way you group them. It usually works out pretty well. Group the terms by common factors. So we're going to change the plus 7x into plus 12x minus 5x. I'm going to group the left one. I'm going to factor out the 2x. 2x times x would be x squared. 2x times 6 would be 12x. Now again, I'm going to factor out, I'm going to take this over here. I'm going to take out the negative 5. And that gives me x plus 6. Now I'm going to factor out the x plus 6 and be left with x plus 6 times 2x minus 5. All right? Your turn. You're going to try both of these, work them out, pause it here, work them out, and see what you get. Come back and check your answers. Okay, on the first one, so A times C is negative 24. So we want them to multiply to negative 24, so one of them's got to be negative, and add to negative 2. I always think about it then, the bigger one has to be negative. For it to add, if one of them's negative, but they have to add to a negative, then the bigger number's got to be negative. So we've got 8 and 3, but those are 5 apart. 12 and 2 are 10 apart. Obviously, we're going to use 6 and 4. I'm going to need negative 6 and positive 4. So I'm going to bunch them that way. I turned negative 6x plus 4x is negative 2x. Now, I can factor out a 6x out of here, and I can factor out a 2 out of here. And it leaves me both of them with 2x minus 1. So I'm going to factor out the 2x minus 1. Get 2x minus 1 times 6x plus 2. Okay, on the last one, 16 times 3 is 48. And we need numbers that are 16 apart. So 16 and 3 are not going to work. What? 12 and 4? Nice thing is we want them to multiply to a positive, or a positive in this case, and add to a negative. So that means we're going to use negative 12 and negative 4. I'm going to show you this one both different ways. Some people will ask, can you write them in different orders? And truthfully, yes, you can. So now we're going to use negative 12x minus 4x instead of minus 16x. Oops, sorry. Sorry about that. So here I can factor out a 4x. And same thing, I'm going to just reiterate this, negative 4x plus 3. I'm going to factor out the negative 1. I know that's weird. Idea being, if I just left this, I'm going to get 4x and 4x minus 3. So I need to factor out and make this a minus. So if I factor out the negative 1, I would get positive 4x minus 3 if I just factor out that negative 1. Okay, and then factor out the 4x minus 3, and there is a 1 right here. So you get 4x minus 3 times 4x minus 1. Now, what would happen if I did these in reverse? So now I'm going to factor out a 4x here and a 3 over here. So again, I'm going to take this. This would be 4x minus 1. Now, I'm going to factor out a negative 3. So it's negative 12x plus 3, and I'm going to factor out a negative 3. So that's going to become 4x and negative 3 divided by negative 3. I'm sorry, positive 3 divided by negative 3 is 4x minus 1. Which, in turn, just equals that. So it really doesn't matter which order you do it in. All right, there's that one. That was a bit of a longer one. Good luck.